So right now we are going to try to do a problem that is related to IDFT, and which is inverse discrete Fourier transform, and you'll be given x of k and you have to determine x of n. In looking into the theory aspect, we have to know that the IDFT formula will be given by this: x of n will be equal to 1 by n summation k equal to 0 to n minus 1 x of k e raised to plus j 2 pi nk by capital N. So we have to know this formula to get an idea about what is the essential kind of things required over here. So we'll start out doing this particular program. Again, this is a question that we have done, and we are supposed to get the answer as x of n equal to 1, 2, 3 and 4. So let's try to begin this problem. So again, as we look over here, we have n equal to 4, which is again something that we already know, which means the stages will also be m equal to 2 by the concept that we already know. Now this method we are still dealing with DIT. So again, the butterfly diagram is the same thing. The DIT butterfly diagram, if this is A and this is B, the twiddle factor comes here and the minus 1 comes here. So this will be WNK. So this will be A plus B WNK, and this will be A minus B WNK. Now the fourth one will be the order of the stages. The order of the stages would remain same. This one would be a 4 point at the end, and this will be a 2 point at this stage. This will be done 2 times, and this will be done 1 time. Where does the actual difference come up is in this particular case of twiddle factor. Now if you look over here, we have to observe a difference over here. The usual twiddle factor WNK was given as e raised to minus j 2 pi into k by n. So we have a small different notation over here when we deal with problems of IDFT. So here the twiddle factor is supposed to represent d raised to plus j 2 pi k by n. Now W, if we assume it represents e raised to minus j 2 pi, then this is equivalent to e raised to minus j 2 pi into minus k by n. So the twiddle factor used for IDFT problems will be given by Wn minus k. So in comparison, the twiddle factor used for DFT problems is represented by Wnk, and when it comes to IDFT problems, the twiddle factor will be represented as Wn minus k. So here we have 2 stages. One is a 2DFT and the 4DFT. So when we look at it, it's a 2IDFT and 4IDFT. So the twiddle factors required here will be W20. The twiddle factors required here will be W40 and W41. So this will be equal to 1. This will be equal to 1. This will be W4 minus 1. So this will be equal to e raised to minus j 2 pi into minus 1 by 4. So this will be equal to e raised to plus j pi by 2, which is cos pi by 2 plus I sin pi by 2, making it I. So if you look over here in the previous problem, we had minus I as W41. Here we are using the twiddle factor W4 minus 1, and it becomes I. And again, the last particular point that we have to observe is the input in the bit reversed order. And when we look at it, the input in the bit reversed order, actual inputs are x of 0, x of 1, x of 2 and x of 3, which represents the x of k. So this is 10, this is minus 2 plus 2j, this is minus 2, and this is minus 2 minus 2j. So when we look at the positions, this is 0 0, this is 0 1, this is 1 0, this is 1 1. When we bit reverse, we have 0 0, 1 0, 0 1 and 1 1. So that will be x of 0, x of 2, x of 3, and x of 1 and x of 3. So that will be 10. X of 2 is minus 2, x of minus 2 plus 2j, and this will be minus 2 minus 2j. So we shall start doing this particular problem using the same concepts that we have used earlier. So we can write the inputs at this point. So this will be 10, this will be minus 2, this will be minus 2 plus 2j, and this will be minus 2 minus 2j. Okay, so now the stage here is your 2-point DFT. So this will be the butterflies. You have minus 1 here, and you have the twiddle factor, that is W20. You have the next butterfly here, which is minus 1 and W20. Okay, so now solving this problem, when we solve this particular diagram, we have at the first point we have 10 plus of minus 2 W20, and then we have 10 minus of minus 2 W20, so which will be equal to 8 and which will be equal to 12. So the output of these two stages will be 8 and 12. Then we have as the next butterfly, when we are solving these two, we will have minus 2 plus 2j plus minus 2 minus 2j W20. So that will be equal to minus 2 plus 2j plus minus 2 minus 2j. So this will get cancelled, and we'll have minus 4 out here, and then we have at the bottom minus 2 plus 2j minus of minus 2 minus 2j W20, again it is 1, so minus 2 plus 2j plus 2 plus 2j, making it 4j. So we have 4j at this point. Now, like I mentioned before, at the second stage we have to implement a 4-point scheme. So we'll be connecting the previous two points. We'll be connecting the upper arm and then the lower arms. So we have this butterfly that will be implemented here, and the next butterfly that will be implemented here. We have minus 1, and we have another minus 1 here. We have the twiddle factor W40, and we have the next twiddle factor W4 minus 1. I hope you get that point. The twiddle factor used as W4 minus 1. So when we solve this butterfly, this becomes 8 minus 4 W40, 8 plus minus 4 W40 actually, and here it becomes 8 minus of minus 4, so 8 plus 4, and then we have 12 plus 4j W4 minus 1 equal to j, and then over here we have 12 minus 4j into j. So solving this, we have 12 plus 4j square, which will be 12 minus 4 equal to 8, and we have 12 here, we have 4 here, and we have j square will be minus 1, so this will be 16. So we get the outputs at 4, 8, 12 and 16, but the answer expected was 1, 2, 3, 4, and we got 4, 8, 12, 16. So for people who have guessed it, you have the answer with you actually, but only thing that you need to do is divide it with n. So if you look over here, we have a basic form. In the basic formula for IDFT, we have a factor of 1 by n, and that 1 by n should be implemented here, and the actual result is 1. This will be 2, this will be 3, and this will be 4. So that solves a problem of a 4-point IDFT using DIT technique, and I hope this video helps.